let's talk about the frequency involving a transformer. If I have a transformer and I say, oh, it's an AC transformer, you immediately say, well, it plugs in to 120 or 220. What is the frequency? It is always 60 cycles out of the outlet, right? If it's not 60 cycle, well, if you're living in Europe, it's 50 cycle. But if it isn't 60 cycle, then something's really wrong. And the equipment won't work unless you're using newer stuff, okay? All right, so it's 60 cycle. But in an aircraft, what is the frequency? 600. So aircraft transformers and generators and everything are 600 cycles. Okay, why? Make them smaller, lighter, and they put out more power, don't they? Okay, if you ever get the chance to build a welder out of a gasoline motor and an aircraft generator, you'll find out that at 60 or 600 cycles, it's really easy to strike an arc, and just a small generator will put out 300 amp. A big, if you do it at a lower frequency, it takes a big generator. I just bought a generator with two-cylinder Cummins engine in it. It's 3-phase, 12 kilowatt, and it's big. Okay, it takes a hefty forklift to pick that baby up. Okay, but it's 60 cycle. I have generators at home that are put out way more than that, but they're 600 cycle. So, okay, so we're talking 600 cycle. Okay, and all the equipment in an airplane is small because of that. Okay, and they rectify it to DC for the radio parts and stuff. Okay, all right, so if we could make a transformer that was higher frequency, we could go ahead and I'm going to say transmit, because it's not really, it's inductively transmit power across the junction at a higher efficiency, and therefore get more energy to the secondary. Does that make sense? So here I have a certain efficiency because of 60 cycle. Why did we do 60 cycle? Because when we first started generating power, we were generating power with 4, 6, and 8 pole generators on steam engines. Steam engines don't run real fast. 1200 RPM, pretty fast steam engine, okay? So because of that, we did 60 cycle. So everything has been 60 cycle from the time we started generating power. Before that, everybody tried to do it with DC. You can imagine how hard it was to get any power through a big piece of cable very far at DC. They figured out that it would take like a generating station every 8 miles to get it to work, or some ridiculously short period. Now we can use power lines that are AC, and we can transmit power from here to California. We raise the voltage up, it's AC, very little loss, boom, off, and does all the work down there. And it just moves the electrons back and forth, so there's hardly any resistance. Okay, so across this junction, we use lamination because solid iron doesn't flip back and forth very fast. Laminations are thinner, less iron. They can change more quickly, 60 hertz, and the inductance can inductively channel the power from the primary to the secondary through the core. Now, higher frequency transformers can't use laminations, so they go to the iron filings that are glued together. Iron filings are little tiny pieces of iron, so they change very quickly. So now we can build a transformer that's, say, 1200 cycles. 1200 cycles. So first thing that we know about transformer is smaller, right? The next thing we know about it is it's more efficient, because more inductive energy can be transmitted across the core to the secondary. Okay? Just like aircraft at 600 cycles. Okay? So we say, okay, if we can do that, then all we need to do is figure out some way to make 1200 cycle power to go into this transformer, right? Okay, how do we do that? Well, if we're talking about a computer power supply, which we are, what we do is we take the 110 volts or 120 volts AC, 60 hertz. First thing we do to it is we rectify it. Okay? Now we have, what do we end up with out of the rectifier? Let's say 150 volts. Now it's not quite DC because we didn't put in the filter capacitors, so we'll put some in. Okay? There, we'll just put one in, okay? Okay, so now we have 150 volts DC. Right? All right, now what do we do from there? Well, if we take that and we run it into a transistor, which we haven't talked about yet, by the way. But if we run it into a transistor, and this transistor comes out and goes to a little oscillator. Let's say just a 555. They don't use that, but let's say we use a 555 because you guys understand a 555. And it pulses at 1200 cycles per second. Oh, okay. So now we have a sine wave, as long as our, not square, it's sine wave. We can make it generate sine wave. Now we have a sine wave at 1200 cycles. We can run it into our transformer. And now we have this voltage pulsed at this frequency into this transformer. We pick it up on the other side and we re-rectify it again. Okay, so it was AC when it went in because of our transistor here. It's now AC when it comes out, but when it comes out of the bridge, we rectify it to DC, and now we have way more efficiency getting it through this transformer, so our power rating's higher. If we bring it out as 5 volt, we can now get 30 amp out of this, because how much can we get out of here? Well, the wall socket's 30 amp, right? 20 amp anyway, okay? Some 30 amp circuits, depends. Let's say it's 20 amp. 20 amp at 120 volts. It's 5 volt at 30 amp. We're well within the parameters of what we can get out of that light socket, right? Or out of that wall socket, right? So, does that make sense for a switching ply? This is called a switching power supply. And all your desktops, all these older ones we're working with, that's what they use. The laptops, the charging unit is a switching supply. So that little block, plug it in wall, plug it into that's the switching supply. It makes the voltage for the laptop to charge the batteries. All switching supplies have this configuration because we make it into a higher frequency. There's different frequencies that they use. Some go clear up to 2400 cycles, okay, depending on the transformer that they use. But no matter what, they produce a higher frequency so that they can get more efficiency across transformers so that they can make a higher output on whatever voltages that they output. Okay? So it's kind of a cute little trick to get this done. Before we had these, the really big computer systems, I've got some power supplies at home that you got to use a hand truck to move them around. They're so big. And they don't put out 30 amp. Okay? So they're big.